Welcome back. This is page 11 in your flip books. This is technically chapter 8, section 4. Today, we are going to be looking at some special products that we get when we multiply binomials together. Yesterday, we learned about the FOIL method and learned that we can multiply a binomial by doing first, outside, inside, and left. And now we're going to use that same idea today a lot to figure out what to do with these three different special product cases. We're going to look at a square of a sum, a square of a difference, and product of a sum and difference. So let's dive right into it. So I've got this expression right here, this binomial that says a plus b all to the power of 2, or all squared. Now, this is kind of like the general form that we use to describe this special product rule called square of a sum. But breaking this down is going to help us with any square of sum that we're going to see, and I'm going to show you an example here in just a second. But we need to remember that squaring anything says that whatever's inside this parenthesis, we are going to multiply that all times itself, okay? So writing this is exactly the same as writing this. A plus b times the quantity of a plus b. And you know from yesterday, using the FOIL method, that we can pretty easily break this down. We'll just do our first, our last, our inside, and our outside. And we get a times a, well, that's a squared. We get a times b, well, that is ab. We get b times a, well, that's ba, or I'm just going to call it ab again. And we get b times b, well, that is b squared. Combining like terms, I see two instances where we have ab, so I'm just going to call that 2ab. And in this box, I'm going to write a squared plus 2ab plus b squared. Okay, so if you start with this, a variable or a number plus a variable or a number, all squared, you are always going to end up with some instance that's going to look like this. Now, this is often going to be a number, and a number squared is just a bigger number, right? So let's take a look at an example. And I'm going to tell you right now, I would use the FOIL method every time. I would rewrite this thing like this and use the FOIL method. Now, this can be helpful when we're doing really complicated stuff, especially if we want to go backwards. But for right now, I just need you to know that this is a special instance that we're going to see a lot these next two chapters, and that this is how it breaks down. But when you get down to actually doing a problem, I would just do the FOIL method, but you're going to see this magic happening every single time. Let's try it. We're going to try E real quick. So this is equal to x plus 4 times x plus 4. I hope you agree that this is equal to this. This says do this thing 2 times. Multiply this thing by itself twice. Okay, now you do the FOIL method. First, outside, inside, and last. And we get x squared plus x times 4 is 4x plus 4x plus 4 times 4 is 16. This simplifies to x squared plus 8x's plus 16. So I hope now you can see that we have something special going on. We've got this x squared from right here. We've got this 4 times x 2 times, right? This 4 times x 2 times. And we've got this 4 squared right here. The biggest problem, though, my friends, is a lot of people are going to call this x squared plus 16, and you're not going to include this 8x. So you've got to be really careful. That's why I do not mind. I actually recommend that you go ahead and break this down and do the FOIL method until you really get accustomed to what happens inside of here. Now we're going to look at square of a difference. So this breaks down to, I hope you can write this without me, a minus b times a minus b. It says to do this thing twice. And so if I do the FOIL method, I get a squared. I get a times negative b. That gives me negative ab. I get negative b times a. Well, it's the same thing, negative ab. And I have a negative b times a negative b. A negative times a negative is a positive b squared. So when I break this down, I get a squared minus, I've got 2 ab's plus some b squared. Notice this is super similar to what I got over here. The only thing is this middle term is going to be negative. This middle term is going to be negative. Okay, let's do an example. So I'm going to rewrite it, but I bet you can see it in here. I'm going to have this squared. I'm going to have negative 9 times x 2 times. And I'm going to have negative 9 times negative 9. Okay? But we're going to do it the long way so you can see what's happening inside of here. So this is x squared. I've got x times negative 9. Well, that's negative 9x. I've got negative 9 times x. Well, that's negative 9x. And I've got negative 9 times negative 9. Well, that gives me a positive 81. I can rewrite that a little bit, and I get x squared minus 18x plus 81. Notice this negative 9 times x twice, and of course our x squared and our negative 9 squared right there. Okay. Now for our third rule, a product of a sum and difference. This one is maybe the most interesting because something really special happens, and we're going to use this idea over and over again to simplify things throughout the years, and this is your first introduction to it. I'm not going to get into more what that's going to look like. I'm just letting you know that this is a really important idea in math because it helps us do a lot of things. Okay, so if I do the FOIL method, like we've been doing this whole time, first, outside, inside, and last, I get a squared. I get a times negative b. That gives me negative ab. I get b times a. Well, that gives me a positive ab. And I get b times negative b. Well, that gives me a negative b squared. Oh my gosh, I hope you're super excited about what you see right here. Do you see that negative ab and positive ab are just going to cancel themselves out? And we're left with just this, a squared minus b squared. Very cool, right? Okay, so our middle term just totally went away when we've got different signs here. Let's try it. Of course, all these things, everything else has to be the same. This has to be an x, this has to be an x, this has to be a 3, this has to be a 3. Okay, let's try it. We're going to do it the long way. This equals x squared. Now I'm going to do last, x times negative 3, that's negative 3x. I'm going to do inside, 3 times x, that's a positive 3x, and I have 3 times negative 3, well, that gives me negative 9. What happened? That went away, and I get x squared minus 9. Well, that's a pretty cool idea that we're going to use a lot to do some things. Well, if you haven't already, and I hope you take advantage of being able to pause this whenever you want, whenever you feel comfortable doing it, I hope you pause it now, because I want you to try these 3 on your own and see how you do, and then come back and see what I did. I might go ahead and cheat on these because I already know what's going to happen. So I'm going to go from here to here. But if you're going to do that, you have to memorize that. You have to know that that's going to happen every time. If you can't remember that, then do it the long way, okay? But I know that this is going to be 2x squared. Well, I need to apply this square to both the 2 and the x. So I end up with 4x squareds. I know I'm going to have 2 of these. I'm going to have 9 times 2x's. So 9 times 2 is 18x, and I'm going to have 2 of those. So 18 plus 18 is 36x's. Finally, I'm going to have a 9 squared, or 9 times 9 is 81. Again, I know that I'm going to have 2 of these. I'm going to have 3x squared. Well, 3 times 3 is 9x squared, so I have 9x squared. I know I have 2 of these things that are in the middle, negative 5 times 3x. So negative 5 times 3x is negative 15 times 2 of those. Well, that gives me negative 30x's. And if you're like, holy smokes, Mr. Gibbs, what in the heck are you even doing right now? Well, then stop. Do these 2 steps first, and then you should see exactly what I'm doing. And then negative 5 times squared, or negative 5 times negative 5, well, that gives me a positive 25. Are you starting to see where these rules are coming from? Finally, here's the cool one. 6x times 6x, well, that gives me 36x squareds. And I don't care what's last or outside or inside, because they're going to cancel each other out. 6 times negative 12 and 6x times positive 12, well, those ideas are going to cancel out. So I can just skip on to 12 times negative 12. Well, that's going to give me a negative 144. But if you're going to take shortcuts, you better get them right. You better really understand why you're doing those shortcuts. Okay? Once you have this done, you should move on to the very next page. It's some practice problems for you. I'm going to be coming around and seeing how you're doing with this. You'll notice that this goes back to the FOIL method. So this is normal FOIL method. This is a square of differences, but you can do it like a normal FOIL method. This is a normal deluxe FOIL method, normal FOIL method, normal FOIL method, and then just in here, here's a product of sum and differences. So just some different types of examples using the FOIL method throughout that you can do. Please let me know if you have any questions. Try some of the harder ones. If you get stuck on them, you know I will help you. Once you're finished with that, you should know what to work on next. Thank you.